Hi, welcome to lesson number 7 on this tutorial series on practical electronics designs. Today I'll be introducing us to a very important concept that will guide us in our next designs, and that is understanding voltage division. Before we talk about voltage division, you have to first of all understand voltage drops. What do you refer to as voltage drops in electronics design? Now let's look at this circuit critically. We have three resistors connected in series, R1, R2, R3. If you remember in my previous lectures, I said resistors are used to oppose the flow of current. So once this circuit is connected and current begins to flow out of the battery, resistor R1 tries to oppose the flow of that current. And in process of opposing the electric charges, a few of those charges, if they have the potency or the energy enough to overcome the resistance, that's if the resistance is not too high to hinder the flow of current, a part of the electric charges will flow through and will flow out of R1. At that point there will be a voltage drop. So if 9 volts was what was applied to the circuit, at this point you measure 9 volts, but at this point where the resistor has had its effect of opposing the current flow, at this point out1, at this point here, you may be having like say 7 volts, depending on the opposition that was caused by this R1, depending on the voltage drop that was caused by R1. So at this point you have say 7 volts. If current continues to flow through R2, there will be another voltage drop at this point, and say let's say another drop of 2 volts, and you have 5 volts at R2. So in my illustration, I'm just assuming that we add voltage drops of 2 volts across this first and second resistor. It's not going to be the case at the same drop all the time. The values of the resistor will affect the voltage drop across the resistor. But one thing you just have to know is that whenever current flows through a resistor, there will be a voltage drop due to the opposition to the flow of that current. And so if 9 volts comes here, you may get 6 volts, 3 volts, depending on the value. I think that is clear. Now, voltage division. Voltage division, a very simple way to model this concept is to use two resistors, R1 and R2, in this form, where we have an input voltage. In the previous circuit I showed us, we had 9 volts, so our input voltage say 9 volts, and we also have, we desire an output voltage lower than that. And so whenever you want to make voltage division, you want to divide voltage into smaller segments or smaller values, you can put two resistors in series. As you can see in this circuit, you have R1 and R2 in series, and there will be a voltage at the output, a V out at this point where the two resistors connect together. So the formula to get your voltage, your V out, your output voltage V out, is this product of the input voltage and R2. So that's V in times R2 divided by the sum of the two resistors or resistance, R1 and R2. So it's going to be V in times R2 divided by R1 and R2. So if I were to assume, for example, that our V in was 12 volts, and the values of our R1 and R2 are 1 kilo ohms and 2 kilo ohms respectively. So you can see R1 is 1 kilo ohm, R2 is 2 kilo ohms. This is just an example. Then using this formula, we will say our V out will be 12 times 2, that's V in times R2, divided by the sum of the resistor values, that's 1 plus 2, and that's going to be 24/3, and that's 8 volts. So we had 12 volts at the input, we needed 8 volts at the output. All we needed to do was just to connect two resistors in series of 1 kilo ohm and 2 kilo ohm, and that way we'll be getting 8 volts at the output. And if you want to get other voltages, you can use the formula, make whatever the subject of formula, and you can get several values as you desire. Now, there are times when you may need several voltage drops across the resistors, or you may need to divide the voltage into several divisions. For example, you can see this circuit here, we have three resistors and we have two different outputs, output 1 and output 2. We could have 10 resistors and have several outputs. A good way to understand how to work with such a circuit when you have several resistors, as opposed to the model that I explained the previous slide where you have just two resistors, is to pick the point where you want to get the output. So if we are getting the output at this point, out 1, every resistor or every resistance value above, or all the resistors above this point, the sum will be regarded as R1, and every resistor value below this point of consideration, the sum of those resistor values will be regarded as R2. So in this case, if you want to get the voltage at R1, we will take our R1 to be R1 because there is no other resistor above this point. So we'll take R1 to be R1. Then we are going to take R2 to be the sum of R2 and R3. So we'll have the sum of R2 and R3 to be our V out, our output 1. If we want to do the same for output 2, we are going to take our R1 as the sum of R1 and R2. So the sum of R1 and R2 will serve as our R1 in the formula, and R3 will serve as our R2. So this approach, you can use it to get the division across several resistors connected in series. This will be a very important concept that we use in our next design. So I believe you understand what voltage division is now. So thank you for watching this video. Kindly subscribe to this channel, click on the bell notification to get notified, the bell notification button to get notified whenever a new video is dropped. Like the video and share. Thank you.